These are all things you've learned, but as we move into the next unit, Unit 5, it is important that you have mastered this concept. So, I have a trinomial. The first thing I look at the smallest number, which happens to be 2. And I ask myself, is it possible to divide a 2 out of 2, 3, and 20? And it's not. I cannot take 3 divided by 2 and end up with a nice whole number. So then I'm going to take 2 times negative 20 to get negative 40. I'm looking for a combination that multiplies to equal negative 40 and combines to give us a positive 3. And that would be positive 8 and negative 5. So plus 8 minus 5. And now what goes in front? Notice that this is not an x squared, it's an x to the 4th. You take whatever that number is, and you divide it by 2, x squared and x squared. The thing a lot of students forget is if this number in front is different than a 1, we have to divide each by that number, which happens to be 2. X squared plus 4, and x squared minus 5 halves. It's common for students to want to think that this is going to break it up into maybe x plus 2, x minus 2, or maybe x plus 2 and x plus 2. Remember, we can only take a difference of squares and factor it further if this is subtraction, and also if the number in front and back are perfect squares. It's not possible. But in back here, since we're unable to simplify this fraction into an integer, I'm going to take the bottom number and push it up. X squared plus 4 and 2x squared minus 5. This will be factored form. Example number 2. Just like example 1, I'm going to start by asking, look for the smaller of the two numbers, which is 2, and is it possible to factor out of 2 for both terms? And it is. So I factor out of 2, I know 2 times 27 is 54. 2 times 1 is 2. Now, also, here I see a cube, and so if you forgot patterns of cubes, 1 times 1 times 1, 2, 2, 2, 3, 3, 3. We have 4s, which is 64, 5s, and so on, right? Well, I can see that 27 is one of the numbers in the pattern, and so is 1. That means this breaks into 3, 1, and x cubed is x and xx. Remember, whenever you do a sum or difference of cubes, in the first parenthesis you'll have 2 positions, in the second you'll have 3, and this is always addition. So I'm going to take one of the 3's and one of the x's, and one of the 1's, and the symbol will go in front. Whatever this symbol is, it'll be the opposite symbol. So if this is subtraction, this is addition, or vice versa. If this was addition, this is subtraction. I've used one of the 3's and one of the x's and one of the 1's in these positions. 3 times 3 is 9, x times x is x squared. 1 times 1 is 1. Now what's this middle term? You're going to have about it being a positive or negative. You're going to take these two terms and multiply. 3x times 1 is 3x, and don't worry about the sign. This is the factored form. If you distributed the 3x and the 1 and then distributed the 2, this is what you would end up with. Example number 3. It's an example of factoring by grouping. We'll look at the first 2 terms. And before I start it, I actually have to start with the smallest number 2. I can divide by 2, I can divide by 2. 15, I can't divide 15 by 2 and end up with a nice whole number. So I'm going to start by looking at the first 2. I can divide a 2 out. I can also take a t out. So I just factored a 2t out of both of these terms. 2 times 3 is 6. I need an r. And I already have a t. 2 times negative 1 is negative 2. I need an s. And I already have a t. Whatever's in parentheses, I'm going